Good afternoon, YouTube. Hope everyone had a happy and safe new year. And I wanted to say thanks to all the viewers and subscribers for 2016, all the great comments and suggestions and ideas for new videos. It's time to get 2017 off to a good start. So on this video, I wanted to talk about some of the things I learned in designing this clip for my LED panel light that I showed you in the last video. I used Autodesk Fusion 360, which you see here, to design this part. So I came from an AutoCAD background. I did a lot of work with AutoCAD in a previous job. In fact, about 21 years ago, I was involved with porting AutoCAD from the DOS and Windows platform over to Silicon Graphics Unix workstations. So I was working with AutoCAD 13 and also worked with release 11 and 12 before that. With my AutoCAD background, I used to use I think they called it the Advanced Modeling Extension, AME, and that's very similar to Fusion 360's Create menu here. You can create boxes and cylinders and spheres and do revolves and extrudes of shapes into 3D surfaces. But for this project, I decided to do a sketch. So that's one of the features that Fusion 360 does. You can make a two-dimensional sketch like you would on the back of an envelope or scrap of paper, and then you can use that sketch to create a 3D model from. So in this case, I used a line sketch, and I drew that line in the XY plane. That way the part sits down flat on the 3D printer build platform and then extrudes up in the Z direction here. So with Fusion 360, they've got a pretty neat feature here. Down at the bottom, you have this timeline. So you can see all the steps that you did to create your model. And in this case, there were 3 steps. So I have this sketch that I created. You'll notice it's labeled Sketch 4 down there. So this is actually the 4th time I redrew this sketch in this particular model file. And I'll explain why I did that coming up here. So let's see, let's go to the sketch, and what we can do is we'll just turn on just the sketch, and I'll go over here to a top view. So here's your sketch that I drew. So this is again a 2D model, and the way you draw that is you just pick the line primitive and then you click all your points where you want all the turns to be. And so I basically built the part off of the dimensions of the panel light. So this is the trim ring flange. It's 2.5 millimeters thick. There's a 9 millimeter recess in the light, and then there's this 1 millimeter thick metal flange or cover on the back. And then I just built the clip to fit around that and to fit inside of the accessory clamp that I'm using to hold this. So that was my final part. The initial sketch that I did, if you remember from the previous video, just had straight sides here. So I basically drew the bottom line, there was a line up to here, and then I did all this stuff in the middle, came over to here and down, but then I wanted to come in here and add these tabs on the top, and I was unable to take this one line segment from the bottom to the top and break it here to insert this intermediate point in this step. And I think I tried all of these. There's a trim, extend, break. I tried all of those things, and I could not get that line to break into 2 segments. So that accounts for one of the erased sketches. It turned out it was just easier to delete the whole thing and start over again. And so the second version of the part, I added this ear sticking out, or this little tab. I came from the bottom up to here and went over and up and back, and That was my second version. When I tried to then taper the sides of the part, as I did in my third and final version, I ran into an issue with Fusion sketches. They have what they call constraints that are added when you draw your lines, and that ties in also to built-in snap grid, where they snap their points to coordinates that are on that grid. So if you draw a line here that's pretty close to horizontal, they will assume you want a horizontal line. They'll draw the horizontal line, and then they add a constraint to that line that says that line is horizontal. If you draw a line up here that's vertical, they constrain that line to be vertical, and then they also constrain those two lines to be perpendicular. Like this angle here is 90, this one's 90, that one's 90. And then there's also constraints that, for instance, this line and this line are parallel. When I tried to move this point in to taper the part, it wouldn't let me do that because this line was constrained vertical and that angle was constrained to be a right angle. So I tried to go in and delete as many constraints as I could see, but it just wouldn't let me do that. So I drew the part again, and this time I purposely drew this line not vertical. And then I was able to move it around because that line and this line were not constrained anymore. And then the fourth time I redrew the sketch was due to the way I had dimensioned the part. I think when I originally drew the part, I put an overall height in here of 33 millimeters. Now what I did to fix that in the last version is I put all of the dimensions inside here. So the overall height is 8 millimeters up to the bottom of this slot, and then 25 up to the top of the clip. And in doing that, this internal geometry here stays fixed. It doesn't move around if I change the outside dimensions. That was the final thing I learned, was you really have to be careful on where you put your dimensions, because if you put them in the wrong place, things inside will start changing. You know, dimensions that matter, if they're referenced to something that doesn't matter, they can change. And the idea was this clip has to fit around that light, and the light doesn't change size. But if I want to make this clip 10 millimeter deep here, or I want to make this a little bit wider, a little bit narrower, that doesn't affect these internal dimensions. So anyway, that's kind of the things I learned, was really be careful when you're doing your sketch. If you want things to be constrained, make them 90 degrees and vertical and horizontal. But if you don't want them constrained, purposely make them not perpendicular, because getting rid of those constraints is pretty hard to do. Here I added my extrusion height, which I made 10 millimeters here. And then I also added a little fillet in here to make the print a little bit stronger. And then with Fusion 360, you can come over here to the Make menu, and you can click on 3D Print. So you can output directly to an STL file if you want to do that. Or you can click here and you can select your 3D printer or slicer utility. I happen to use Cura, but they have some other options there as well. And then you just select your part and click OK, and then that sends your model over to, in this case, Cura. This is the default height, and in fact, if we go down here to scale, you can see it's 28 by 33 millimeters, 10 millimeter tall. One thing to do is go over here to the uniform scale, click that button to go into non-uniform scale. It's kind of hard to see. There's just a slight bit of the button disappears there. What that lets you do then is, if you want to make your part, say, 20 millimeter tall, you scale it by a factor of 2, If you want it 70 millimeter tall, put in a factor of 7. And let's see, that says it's just short of 3 hours to print. You go up here, send it to your printer, and a couple hours later you have a part. So that's about all you have to do. So yeah, I just wanted to show you a little bit of the design process on this clip and some of the things I learned in using the sketch feature in Fusion 360. Really nice program. If you haven't checked it out, I would take a look at that. If you have any questions or comments about that, post up in the comment section below the video description down here. As always, thanks for watching.